Abu, thank you very much. One more talk, which has got a technological basis. Every country in the world is trying to reduce their carbon emission, and they are looking at solutions which can be green. And for that, they are looking at technology which will help them to achieve the goal of reducing carbon emission. So today we're going to talk about two new technologies which have not been implemented in full scale in any country in the world. No country has got these two technologies implemented in great length. So I'm going to talk about these two technologies. And in one of the technologies, India is a leader. As you go along, you will appreciate in which technology India is the leader. Essentially, it is pertaining to how the present carbon emission can be reduced. And solutions are normally global in nature, but they can be country-specific solutions as well. So with this, I will upload my presentation. India is waiting for these two technologies, which I'm calling green steel and green coal, how they can be implemented and how we can reduce our carbon emission. So let's start a brief introduction. India has got multiple targets to be achieved by 2030 in respect of carbon emission, which were committed by our Honorable Prime Minister in COP26 meeting at Glasgow in 2019. And one of the targets is to reduce carbon emission by 1 billion ton from the 2020 emission level to 2.9 billion tons, which was existing in 2020. We want to bring it down by 1 billion tons. And how do you bring it? You bring green hydrogen, you bring afforestation, coal management, alternate fuels, renewable energy. So many methods the country is trying. All of them don't give the same level of results, but we have started quantifying the results which we have so far seen, which I'll talk about as we go along. The power in industry and transportation sector, the power sector, industry sector, and transport sector, they contribute to 55, 25, and 14% of India's carbon emissions. Power is the maximum at 55%. Then comes industry, then comes transportation. And coal is the major cause of the emission in power and industries, not for transportation. There are hardly any trains running on coal now. There are hardly any ships running on coal now. So coal's adverse impact is on power sector and industry sector. And one of the major polluting industries is iron and steel, which emits 0.25 billion tons of CO2 every year. Similar high values also exist for other industries like cement, fertilizer, refineries, etc., where coal is used. So wherever coal is being used in industry, you have an issue of CO2 emission because you're burning coal. With this background, let's go forward. So let's look at steel production in India. Steel production in India, the capacity is 167 million tons. And you can see wherever it is brown in color, it is very high steel production. Then comes orange, then comes blue, and then comes red. So we are able to, and of course, last is gray. We find it's mostly in the central part of India where coal is being utilized maximum for the industries or for coal, etc. So let's, for steel production. Capacity is 167 million tons. production last year was 143 million tons. That's we are come to very close to something like 80 plus percentage. Private sector is contributing 87% of the production. JSW, Tata's, Mittal, etc. And public sector is only 13%, SAIL, Hindustan Steel. And the world rank for India is number 2. But we are producing only 7.5% of world steel. China is in rank 1 with 54%. 54% of steel of the world is produced in China. They also have lots of carbon emission problems. We'll see the next slide. But the fact is, they have monopoly over steel production in the world. So I'm going to show you a little bit of metallurgy combined with some physics. Let's see that. Steel is produced in two manners. One is the red circle and the other is the yellow circle. I will explain that very briefly now. In nature, steel, we get steel, we extract steel from iron ore. Iron ore is mined from the ground, from mines, coal mines, or from iron mines, which is in the form of ferrous oxide. And then we try to get the iron out of it. From the ferrous oxide, we take away iron. There's another method, which is the yellow circle, which I'll explain to you, is you burn scrap steel, collect scrap steel, burn it, recycle it to get steel again. So there are two different ways of doing it. So let's go into a little more details. In the primary method, iron ore and coal or coke are broken down together and they are fed into a blast furnace. Limestone is also added to help the chemical process. And this blast furnace is fed hot air and oil. That's how the fire is sustained. Now, in this heat, the iron ore releases oxygen, and that combines with the carbon of coal or coke to form CO2 and get discharged into the atmosphere. So iron ore is split into iron and oxygen combines with carbon and carbon dioxide is produced. I'm putting it very simply. And that's how we have a lot of CO2 emission from a steel factory. This primary method emits nearly 2 tons, 1.987, nearly 2 tons of CO2 per ton steel, which is generated in the steel plant. The residual part of the ore, after the oxygen is gone, is iron, which is heated once again in another furnace to improve its purity. And then there are various additives added for different types of steel. You want some steel which will have tensile strength, some steel which should be able to you can able to draw it in the form of wire. Some are flattened to sheet. So different types of steel is available in the market from the factory. Customers also want it in different shapes. And to get them manufactured, there are some additives are added. So this is the primary method of making steel. Burn iron ore with coal, and iron is left behind and CO2 is emitted. This is a primary method. Now let's see the secondary method. Secondary method is very simple. Scrap steel is melted in a furnace like here I have shown in the circle, and it's purified. That scrap steel melts and then it's purified, and less CO2 is emitted, something like 0.35. The first one was nearly 2 tons. Now it is 0.35 tons of CO2. So if you can collect scrap steel and form again, purified steel based on your requirement, then you don't emit so much of CO2. But then you should have a strong supply chain for it. You should be able to collect the scrap back. You should be able to powder it or break it into small pieces, then send it to a factory. And in the factory, they have to smelt it, etc. So these are very quickly two ways of making steel. Now, if you look at emission, carbon emission, globally, we are around 37 gigatons at this point of time, out of which China is this yellow colored graph, more than 12 and a half, nearly 13. India is this gray one, which is coming very close to 3. And rest is this is USA and this is EU, etc. Right-hand side is per capita, but that's not of much importance in this discussion. We look at total emission, we are very close to 3 gigatons of CO2. Now, in this CO2, 3 gigatons or billion tons, they are same. There's no difference. The unit is the same. You can call it either billion tons or you can call it gigatons, which is almost little over 8% of the global total. Now, India steel industry, there are about 900 steel plants. Some are big, some are small, some are in the private sector, some are in the public sector. They generate 0.25 billion tons of CO2. That means 1/12 of our total emission is from the steel manufacture, which I told you, which is around 2 tons of CO2 per ton of steel produced. Now, if you want to reduce this carbon emission, then the industrial process has to get changed. Then only emissions can reduce. So the primary manufacture, which I talked about, we want to avoid coal. Instead of coal, let us burn something else, some other method by which we can get iron out of ferrous oxide and we will not produce CO2. That is the aim. So if you can reduce the net emission from 2 tons per ton of steel to something like 0.6 ton of CO2 in a primary method of manufacture, then as per new international norms, you can call the steel to be green steel. It is not zero emission, but 0.6 tons, because it is not only carbon emission from the coal furnace, it is also emission from power required to run the furnace, run the other equipment, run blowers, operate the factory. They all require power, and the power is coming from some other power plant, which may be thermal. So on an average, it comes to around 0.6. But if you can get anything less than 0.6, you can call yourself that you are making green steel. So let us look at what is green steel. So there's a furnace. I'm repeating what I said earlier, conventional process. There's a furnace. There's the broken coal and iron ore are broken and put into the furnace. Then there's hot air and oil coming from here. And inside the furnace, in this heat, the iron ore is broken down and you get iron and carbon from the coal with the CO2 from iron ore becomes CO2. This is our problem. This black smoke which comes out of the steel factory is our problem. We want to reduce this. So let us look at what happens in green steel. This is the technological change. I have simplified and shown, but let us quickly see. Furnace, this similar type of furnace. I'm not saying it is identical furnace, but a similar type of furnace is there. Here, it's given only broken iron ore, no coal. Earlier it was coal plus iron ore, now only iron ore. And hot air we were giving earlier, now we give hydrogen. So when we give this inside the furnace, and you have this iron ore and the hydrogen coming. In this heat in the furnace, iron ore, which is ferrous oxide, splits into oxygen and iron. And the oxygen combines with hydrogen to form H2O, water. And you get green iron or green steel. Where the green iron will become steel after some time when it is purified and some additives and all are added. So when you want to have green steel production, there's no carbon dioxide. It is H2O. But why? Because we are introducing hydrogen. How can you introduce hydrogen? Hydrogen is not available in the atmosphere in large quantity. Where will you get it from? You can't bring it in a cylinder and feed to the furnace. Furnace requires large quantities of hydrogen. How to get it is the issue. So let's see the next slide. So you have this green steel production setup. Hydrogen has to come from somewhere. So you have an electrolysis plant. So one separate factory or a separate plant which will split water into hydrogen and oxygen. You take away the oxygen and give it for whatever use is required for oxygen to other industries. And in this electrolysis plant will supply hydrogen to the furnace. And it will help this conversion of ferrous oxide into iron and H2O. That means you have to set up an electrolysis plant very close to the factory. It can't be even 5 kilometers away. I'll tell you why. Because hydrogen is a very light gas, very voluminous. It cannot be put in cylinders and brought. You'll require thousands of cylinders then. So it is normally brought under pipe in a pipeline under pressure from the electrolysis plant. So we set up an electrolysis plant 2-3 kilometers away and do it. But electrolysis plants require power. How will you operate it? If that power is coming from a power plant where you're burning coal, then you're not actually reduce carbon emission. That electrolysis plant should work on power which doesn't involve coal. It can come from a nuclear power plant. It can come from a windmill, or it can come from a solar panel or solar farm. So you set up another solar farm or a wind farm to feed the electrolysis plant, which means steel factory requires additional land to set up electrolysis plant, set up windmill or steel solar farm, so that what is coming here, energy which is coming here is not related to coal. No fossil fuel, no diesel, no petrol, no coal. So the electrolysis plant get a pure energy, which is green energy, and then gives hydrogen. And therefore you call this hydrogen green hydrogen. Because it is coming from an electrolysis plant fed with green energy, you get green hydrogen. If you feed energy from a thermal power plant burning coal, electrolysis plant will still work, but the hydrogen will not be green. It will be black hydrogen. If you feed from a nuclear power plant, it will be purple hydrogen. We have discussed this earlier. So let's come back to this. So you require space for these two additional setups in the steel plant. So steel plant requires capital investment, requires electrolysis plant, renewable energy, or you can take renewable energy from green grid. We discussed this some time back. They are trying to run a separate grid with only green energy so that it can be given to industries. You require additional land also sometimes. So the cost of green steel will be higher because of this. Apart from, there is some modification required on the existing furnace. But carbon emission can be reduced. So the first technology which you are seeing is do away with coal, get hydrogens, put up electrolysis plant, put a renewable energy source, and you will have less carbon emission. Now, for 1 ton of green steel, 1 million tons of green steel, you require 5,000 tons of green hydrogen. And green hydrogen is light. So you can imagine the volume of green hydrogen required. You require so many gigawatts of power for running the electrolysis plant. That means you should have a solar farm or a wind farm or power from somewhere in the green grid, which will at least give 0.7 gigawatts of energy. So it's a huge amount of energy required to produce the hydrogen, which will go for formation of steel. So green steel, we can have less than 0.6 ton. This is the present international accepted norm. But there's no standard still defined internationally. What is green steel? It's not green color. Definitely it's not green color. It is the way the steel is manufactured using green hydrogen. Hydrogen also got no green color because the energy it uses is green. That's why it's got green hydrogen, and therefore the steel has become green steel because coal is thrown away and hydrogen comes and you're able to manufacture. That is a major takeaway for you for today, this technology. And EU has said presently an interim threshold of 1 tons, that if you have a steel which is produced with less than 1.8 tons, then we'll accept as import. Otherwise, we'll levy a penalty. You remember earlier it was 2 tons if you use coal. So they brought down the level slightly to 1.8 for 2026, saying reduce the carbon emission a little bit by improving your manufacturing, and then we will accept imports from other countries, otherwise levy penalty for every ton. Today, there's only one firm in Austria, which produces green steel. Only one in the whole world. It uses a 6 gigawatts electrolysis plant. You see here on the left, 1 million ton requires 0.6 gigawatts, but this uses 6 gigawatts. That means it can produce 10 megawatts of steel. And so far, it's under trials and various other improvements are being made. It has only produced 5,000 tons. But commercial operation is going to come from 2030 because electrolysis plant is to be made, pipelines had to be run with hydrogen, they had to be pressurized, compressors are required, and green energy has to come. So they anticipate another 5 more years before commercial level operation can happen in this factory, the first factory in the world, which has been started in Austria. There are 10 projects going on in progress in the world. Many are in Europe, 2 in USA, and 1 in UK. And the 1 in UK is owned by Tata's. Tata had bought many steel plants in UK, and one of them is doing the conversion to green steel. Indian projects are yet to start. So in India, no green steel is produced on commercial scale. R&D is going on, experiments are going on, people are trying to see how to produce green steel because that is the requirement of tomorrow. Definitely we want to bring the carbon emission. So there are major Indian companies that have started making green steel production plans. How to do it? How shall we modify it? What is additional equipment required? Where's the land requirement? Where's the energy going to come? Okay, now let us look at what is the plan of the various private industries as well as public sector in India. JSW wants to, by 2030, this is Jindal's JSW, 1.95 tons per ton. SAIL, which is a public sector, he is going to stick to 2.2, is present, slightly reduced. Tata wants to bring down to 1.8. ArcelorMittal or Nippon Steel, is a joint venture, they want to reduce to 1.8. So this is the plan of our major steel manufacturers in India. 3 are private sector, 1 is public sector, and they are bringing in some improvements, as you can see in the slide. have set their emission target by all these plants by 2030. Tata's and set up at so and so, as I told you, and SAIL is at 2.2 tons. Tata's, in addition, are planning to induct small nuclear reactors. You must have seen in the paper after budget that the government is going to give some money to make small nuclear reactors, which is going to be called Bharat. They can be a part of the steel plant as an extension, so that they don't require solar, they don't require wind, but they can power the electrolysis plant and the steel plant. Tatas are trying to do this. It will take some years, definitely. And they will be inducting these nuclear power plant. And if they're going to use this, their hydrogen will not be green. It will be called purple. Indian coal is not preferred by many steel industries because of high ash content, and therefore they need to be desirably substituted by imported coal, which has got lower emissions. This is another problem with Indian coal, and therefore Indian steel manufacturers have a problem. If you use Indian coal, and if government doesn't allow import, then your ash content is high, CO2 content also will be high. Per ton, you will be producing more CO2. So, while this is all pertaining to primary sector, a higher amount of scrap steel, if you can bring through your circular economy activities, that means collect the scrap, break it down to smaller pieces, bring it back to steel manufacturer who will just recycle the old steel. This is another way of doing it, also of reducing carbon emissions. So two methods. One, go for green hydrogen, or like Tata saying, go for purple hydrogen, or shift to more of collecting scrap and then doing it. Let us see how the companies are doing it, our Indian companies. They have completed their study, and they feel about 30% of the existing furnaces can be reused to accept green hydrogen with small modifications. Kalyani Group, which is in Pune, they have utilized an existing electric furnace to demonstrate green steel production called Kalyani Ferresta using scrap steel. So they have gone to secondary method of manufacture, and they have modified an existing infrastructure to produce a green steel. It's only a demonstration, not a commercial level. L&T has commissioned the first indigenously manufactured electrolysis plant with a rated power of 1 megawatt. Remember that you require nearly 0.6 gigawatts. That is 600 megawatts for 1 million ton. So, but this is only initial manufacture, first indigenously manufactured. They are getting about so much of 200 cubic meter of hydrogen per hour. They are trying to manufacture and utilize it for steel plants. They will make the electrolysis plant and give. And JSW has allocated a 4 MT unit for green steel conversion with an emission target of 0.6 to this thing. So let us go and see what further is happening in India. Government has set up a green steel mission with a budget of 15,000 crores to assist steel plants so that they can be loan for electrolysis plant or for getting energy from grid, etc. And minimize the import of steel. That means use as much as Indian steel within the country, because many of them don't clear that threshold which is kept. They will get into penalty. So don't import, utilize our own steel within the country. Customs duty on 2 items which are required for steel process, government has abolished in the last budget. Safety guidelines has been reviewed. Import of low ash content is permitted now. That means you can import low ash content coal because you want to go to green steel. So this is another initiative which the government has taken. And they have evolved steel taxonomy vis-a-vis emission rate. If you are less than 1.6, 5 star. Otherwise, if it is between so and so and so and so, 4-star, 3-star, and no rating if you are more than 2.2. So the first time in the world, rather, some standards have been evolved by Indian government for seeing how the steel will be called, whether it's 4-star, 5-star, or 3-star, depending upon the emission rate in the factory. That means they will be having an agency who will monitor the emissions and who will decide what grading should be given to that product coming out of that factory. So these are the changes which are going to happen in the next 4 or 5 years. And we should be soon having company after company, JSW or Tata's or SAIL, coming out with green steel. But what I told you is what is important. That means their manufacturing process is being tweaked to accept hydrogen instead of burning coal. So let's go to the next technology called green coal. This coal is not again not in green color. It converts municipal waste, which is segregated. That means you remove the plastic, remove items which cannot be burned, but items which can be burned, which is vegetable waste or wood items, or something which is paper, etc. All those things can be waste, which can be burned. You segregate them, and you do a technology called torrefaction. Many of you must be seeing this word for the first time. That means you do the combustion of this waste in an oxygen deficient condition. That means you put them in a furnace and make sure no oxygen is allowed to enter the chamber, or very little oxygen is permitted to enter the chamber. This is called torrefaction. This torrefaction will make sure that this municipal waste is converted to charcoal. You remember, we used to have the people who press your clothes. He used to make charcoal in front of his shop by burning wood. And then he used to cover it in such a way that it doesn't get burned out fully, but it remains still as black pieces which you can recover and use it for his press. That is similar to something similar, but here it's a big chamber where you have this torrefaction, convert to coal, and that coal is mixed with some binder and pellets are formed, and that is called green coal. It doesn't look green, it looks black only, just like what the Dhobi has got in a shop. So this is the technology. Now let us see where we are in India. So this is the biomass, raw biomass after segregation. This is the torrefied biomass, and this is how the pellets look. Many barbecue stands use this. Many old type of press use this. There are many other ovens and furnaces which use these type of pellets. So you first dry it. When you dry it, all the moisture goes away and the weight of the biomass reduces. Then this biomass, dried biomass, is done for torrefaction when it's under heat in the furnace. In the furnace, some more things which are volatile burn away. Some of the cellulose will burn away. Some of the volatiles will disappear. And the moisture also will go away. So the weight comes down, and what is remaining is like charcoal. In the West, it's called biochar. Biological charcoal is now called as biochar. And that mass, those pellets, are used to burn in furnaces where it can be for power generation, it can be for other industry. We will see where are the applications. So India has got huge potential. In more than 200 million tons you can remove of CO2 from our present. Our present is 0.25 billion. That is 250 billion. We can remove 200 out of 250. if you can get biochar popularized in the country. That means if you can get all the municipal waste collected and converted to biocharcoal, and that charcoal is used in industry. It need not be only municipal waste, it can be farm waste also. China has got a huge potential, Brazil has got huge potential, USA has got potential, India has also got a significant potential as per some study, but it's not easy to reach this level. So let us look at what are the differences between biochar and green coal. We talked about two things. One is green coal and one is biochar. The small differences are there. Coal is produced at a higher temperature, green coal, 800 degrees. Biochar is at a lower temperature. Volatile content is higher in biochar, and therefore its calorific value is less in biochar. That means you can use that biochar only in those applications where you don't want too much of heat in the industry, which is required only for heating up water, converting into steam, or for some other liquids or some other chemical process where you don't require very high temperature, like you require in a steel process. Then you go for biochar. Biochar can also absorb water. When you want to cool it down, you can do it with water as compared to coal. Coal is not so easily absorbing the water. Biochar also can be used for soil conservation and when you want to recharge your soil with nutrients. So it is used in soil fertility, pollutant absorption, etc. While green coal, which is produced converting municipal waste at a high temperature, less oxygen, high temperature, it can be used for power generation, power plants, industrial combustion, boilers, etc. So municipal waste, which is like this, gets converted to green coal. So where have we done it? The first green coal plant in India came in Varanasi. It was demonstrated by National Thermal Power Corporation, a PSU, in collaboration with another company, Macabre BK at Varanasi in 23, just about 2 years back, where they produced 200 tons a day. After 1 year, they improved the performance and it's about 600 tons a day. I'm sure the problem must be to get municipal waste segregated and brought to that factory. The key technology is torrefaction, which I've already explained to you. NTPC is planning to set up additional plants in Noida, Bhopal, Hubli, etc., as per the capacity shown there. NTPC plans to use this green coal in their own thermal plants. NTPC is burning coal today to produce electricity. So after these plants, green coal plants, they will reuse that green coal in their own thermal plants. Thermal power plants, it is still thermal, but not using fossil fuel coal. They'll be using green coal, which have been obtained from biological waste or municipal waste. 1 kg green coal produces 2 kg less of CO2 as compared to conventional coal. So there's a reduction of about 60% of pollution if you go for green coal. Now, this is how it looks, photograph, almost similar to biochar. The merits and demerits of green coal. Pollution and smoke are reduced, very clear, as compared to conventional coal. Municipal waste can be managed better. Imagine you've got a power plant with conventional coal that has to come from a mine, which may be in Bihar or Chhattisgarh. From there, it has to come by train. From train, it has to come by truck to your factory, your steel plant, and then used. But if you're using municipal waste, you can get it collected from one of the new plants, torrefaction plants, nearby, which collects municipal waste of nearby areas and utilize. So you will have easy logistics for your green coal as compared to conventional coal. And you're also able to manage your municipal waste. Otherwise, where will the municipal waste go? You won't go and put in a landfill. Land is filled. It has become a hill now, like you have seen in Delhi. So a better management of municipal waste will evolve. It can be set up in different locations depending upon where the users are. You maybe have an aluminium plant, so set up some green coal plants in the nearby towns. You may be having some paint factory which requires heating up and things like that. You set up a green coal factory there. So green coal produces higher energy density. I want to clarify this. Higher energy density is different from higher calorific value because it is all the moisture has gone away, all the volatile items are burned away, the remaining mass is less, and therefore it's higher energy density. That's the reason. But calorific value is, as compared to coal, it is less. You can, as I told you, municipal waste, if you send to a landfill, it will decompose and produce methane, which will add to greenhouse emission, greenhouse gas emission. So municipal waste is better managed locally rather than collecting it all in one place and creating a huge dump yard with all the waste producing methane. So green coal has got huge potential, not only in the applications of energy giving, but also in disposal of municipal waste. Farm waste also can be. So pollution in Delhi, if you use this technique, it can be brought down. Collect all the waste and convert it into green coal by having a plant, maybe in the Noida plant, which is going to come up there by NTPC, will do this. So let's come to conclusions. Countries are pursuing different technologies so that they can avoid fossil fuel. And the difficult solutions are in what's called hard to abate industries: cement, steel, fertilizer, refinery. They all got set up in such a way they require coal. They're coal hungry. So you have to shake them off from coal and they have to use some other process which is more green. So in conventional steel manufacturing, when you converted ferrous oxide to iron, releasing CO2, when you brought H2, hydrogen, then minimum CO2 emission, as I told you, because power is still required for other operations. And if you can get it from electrolysis plant, it will be green hydrogen. Otherwise, depending upon where the power is coming from, the hydrogen color will be different in its calling. It's only in the term, not in the actual color. First plant in Austria, I told you, and it is progressing. For every ton of green steel, 65% carbon emission is reduced, which is very good. So we should try and get this technology as early as possible in the country. Our steel industries are getting ready. Government has introduced many policies to encourage them. Productive link incentive, electrolysis plant, some additional money. They brought taxonomy so that you know what is your grade of steel, custom duty exemption, so many things they have done recently. As regards green coal, which is only made for the first time in the world in India. India is a leader in green coal. The Torrefaction technology, which has been demonstrated in Varanasi in the plant, you converting municipal waste, it will have very similar calorific value to conventional coal, slightly lower, but much reduced emission level of CO2. So green coal, as I told you, gives not only energy solution, but also solutions for disposal of municipal waste, avoiding landfill, and even pollution to water, which can happen. There's a variant of torrefaction technology. If you reduce the temperature the chamber, you'll get biocharcoal or biochar, which can be used for applications which require less heat, and also for some applications to improve the soil fertility, etc. Environmental protection, things like that. So this torrefaction technology can be used at a higher temperature level for green coal, or a lower temperature level to produce biochar. So if we can get these two technologies consolidated in India as early as possible, we will be able to reduce a significant portion of our industry's emission of CO2, which are emitting now 250 million tons or 0.25 billion tons. Our target is 1 billion ton, but that can be achieved through many ways, not only from industries, from transports by going to green vehicle, by afforestation, which can absorb CO2, going for alternate fuels. You remember some time back we discussed ethanol blended fuel. So when you blend ethanol, CO2 level reduced. So many techniques had to be followed. One of the techniques is induct green steel and induct green coal. Inducting green coal, India is the pioneer. For induction green steel, India's world number 2 in steel production. So we have got a huge potential to reduce carbon resource if you go the green steel way. That is why government is giving so much of importance to producing hydrogen in the country, preferably from renewable energy. And therefore they say green hydrogen is required in great quantity, not only for domestic use, but also for export. With this, I come to the end of my presentation. I've talked about two